All right, welcome everyone to session 7 of Coding Live in Python. Today we're going to be talking about Truthy and Falsey and about recursion. So let's go into Truthy and Falsey. So the concept of Truthy and Falsey is just evaluating what type of data types are considered to be false and which ones are considered to be truth or true. So each value has an inherent Boolean value, generally known as either Truthy or Falsey. So here we see all the Falsey side and the Truthy. So false is obviously going to be false, just like truth would be true would be Truthy. The number 0 is Falsy, but 0 in string is Truthy. And the reasoning behind that is because any string that's not empty is truth, right? So a string containing a single 0 would be Truthy. In this case, we see that both of these strings are empty, so they're considered to be false. An empty string in an empty dictionary are Truthy, and none is considered to be false. So let's just cover that really quickly. All right, so Truthy and Falsey. So let's say, so I wanted to print hello, or actually, let's say if, let's just leave an empty string, print Truthy. Else, Falsey. So we see that we get Falsey, and that's because it is an empty string, right? So if I were to put any type of letters in there, and then run this lesson file, now will become truth. Okay, so now let's see. The next one was 0. And we see Falsey for the empty string. And then we see 0 is also Falsey. Now, let's say if I made it 1, and I run that, now we see Truthy. Now, if I made 0 and then into a string, would this be Truthy or would this be Falsey?
Truthy.
It would be Truthy, right? And then the reason why that would be Truthy is because it's a string that actually has some type of content inside of it. It's not an empty string. So when I run it, we see Falsey and Truthy. Okay, great. So let's see what else we got.
Are negative integers truthy too?
Yeah, so let's check out negative integers. So if -2, print Truthy, else print Falsey. And let's just comment out these so that we don't get any type of white noise here. So we see that it's Truthy. So it's pretty much the same content behind the empty string, right? 0 has no actual value inside of it. And because it has no actual value that corresponds to 0, it keeps coming back Falsey. But -2, that's a value. Just like +1 or +2, any type of negative number actually has some sort of value or input into the machine. And that is why it comes out Truthy. So for example, if I said, if none, print Truthy, else so now we see that none, right? None has no actual data structure that's attached to it or any type of value attached to it. And because of that, it is Falsey. Covered this. Oh, and then we got our data structures. So now here's the question, right? So we know that an empty string returns Interesting. So this is actually falsy as well. So our slide is wrong. This is falsy. And I wonder if our dictionary is also false. Okay, so both our dictionary and our list are false. Can you guys think of a reason why?
Java.
Say again?
Those are for Java, not Python.
Oh no, yeah, I know why these are, are wrong. Thank you. But what I'm saying is, why would these return a falsy statement instead of a truthy?
Is it because there's no value to them?
Right. It has no content inside of it. There's nothing in it. Right. So now if I were to put an empty string, so now I wonder, it has a value, right? So the list itself has a value. It may be an empty string, and an empty string has no value. So technically the inside of it would be falsy, right? But the list now has at least an index of 0, and it can access something inside of it. It has a value that's attached to it. Whereas before, when it was empty, when I ran it, what's going on here? I think it's just not saving. There you go. When I ran it, it returned falsy. So that's just the difference between truthy and falsy. Obviously, there's also false and true. But everything else is just determined by the ability of the data structure that you're using, holding an actual value inside of it. All right. The perfect example here is we see string. The empty string would be falsy because it's empty. Here we see a string of 0, where that would be truthy because now the string has an index, it has values, it has things inside of it. When we go into -2 is an actual value, so it comes out truthy. And if I were to turn it back into 0, we would get false because 0 is a value of none. There's nothing inside of it. Just like none. None returns false. And empty list, along with empty dictionaries, will also return false. And let's just test the dictionary out real quick. And we get falsy. And if we put a key in there, ooh. Now it comes out truthy because it has an actual key value pair inside of it. Awesome. So now let's check out our last one, which is tuples. We see that tuple being empty returns a 0 or returns falsy. Now let's say I put 1 in there and I run this, and now returns truthy because again, it has a value. So if I put a 0 in there, it now returns falsy, which is different than what we had up here. Right? So let's see. Let's turn this into a list and put 0 in there. Okay, so there's a difference. So when I'm doing things in list, if I put the value of 0 inside of a list, it now has an index, and that also has the ability to be manipulated, right? I could do variable reassignment to the index of 0 and put something else inside of a list. But when I'm using a tuple cannot be changed, and all the data inside of it is set. If I put 0 inside of a tuple, or a value that's of 0 inside of a tuple, it will return false. Same thing with the string. Still returns false. Now let's say that I put something inside of the tuple like this. A tuple will always remain falsy because it has no other functions but to store the information that's inside of the tuple. Does anyone have any questions over truthy and falsy variables in Python?
So for tuple, so if it's a string and it's empty, it's gonna always be false. Then if it's a number, because I tried number return, it came out truthy. So
So
if it's number.
Yeah, let's turn it back into a number. So let's say we put 2 in there. Let's save it. Let's run it. Comes back truthy, right? But when I put a string in there with actual values,
Yeah, it's false.
still comes back truthy, right? It just wasn't saving before. That's why it showed false. I didn't realize it was showing false until now. So if I turned it empty, it's now going to return false. All right, because it's grabbing the data structure inside of it and determining its value. The tuple itself can't hold a value necessarily because a tuple doesn't have any type of functions that go to it. I can't do variable reassignment with a tuple. I can't alter the data inside of a tuple. So therefore it doesn't have a value. If I put 0, so now the tuple, when I run this if statement, it goes into the tuple and grabs what's inside of it. It sees the 0, and the 0 is still equivalent to nothing, so it returns falsy. Whereas if I put 2 and then save it, we'll see that it's truthy, right? So let's see. We have falsy, we have truthy, and let's say we have falsy all over again. So when I turn it this way, oh, I apologize, everybody. This wasn't even recognizing it as a tuple. Okay, so it's going to return truthy, right? If I turn it back into an empty string, it returns falsy. And let me just make sure that it is recognizing it as a tuple. Okay, so it returns truthy. So now here, let me show you guys the error that it showed us. So you see this yellow squiggly line? It tells us if tuple literal is always true, perhaps remove accidental comma. So it's saying that a tuple will always be true. So I apologize for giving you guys that wrong information, but a tuple will always be true. Okay. Let's move on to recursion now. So now recursion, recursion is a pretty useful tool, and it avoids us from being able to have too many loops inside of our code. So instead of having an extra loop, I could just call my function within my function. So the process is in which a function calls itself. Using a recursion to solve a problem requires 2 cases. A base case, the condition in which the function will stop, and a recursive case, the case in which the condition will return itself. So here we have the function of sum up to with a number. So we have the base where the number is equal to 1, then it's just going to return 1. Otherwise, it's going to return the number plus sum up to of number minus 1. So here's how it works in recursion. So the original call is sum up to of 5. Takes in 5. 5 is not equal to 1, so it goes into the else statement and returns 5 plus sum up to of 5 minus 1. So now we see the next case where sum up to is 4. 4 is not equal to 1, so it goes down and says 4 plus sum up to 4 minus 1. So now we see 3. It returns 3 plus sum up to 3 minus 1. Now we see 2, which returns sum up to 2 minus 1. And then we see sum up to 1. And now the sum up to 1 now meets our return statement. So if 1 is equal to 1, return 1. So now we get the value of 1 returned here. So now we see 2 plus 1, this is 3. It gets returned here. 3 plus 3 is 6. Moves up here. 4 plus 6 is 10. moves back to our original call, where 5 plus 10 is 15. And here's a better way of seeing it. We see 1, 2, 3, 4, 5, and our final output is 15. Does anyone have any questions about this?
So if we were to be using loop, we're gonna be doing loop for 5, 4, 3, 2, 1. Is that what this thing is recursion is trying to solve? Instead of having those step of loops, we're having just one if statement with a returns.
Yeah. So let's see. There's two ways of solving this, right? Let's say sum up to 5. And what this function could do is it could be a while loop where as long as 5 is greater than 0, we could have a count, or I guess answer. And what I can do is say answer plus or equals, and let's have I be equal to num. And here, let's say I, as long as I is greater than 0, then answer plus or equals I, and then I minus equals, or right, minus equals 1. So let's say I run this. And I put 5. So we see none. And now I'm trying to figure out why it's giving us none. Oh, because it's not returning anything. Ah. There you go. So it returns us 15, right? And let's just create a counter. Let's make that equal to 0. And every time it goes to the while loop, we're going to make our counter go up 1. So we see it did that in 5 times, right? It went 15 5 times, and it did the entire while loop. Now, let's say that if in my while loop, I happen to use the wrong sign. Let's say I made it equal to 0, right? While say it's not equal. And then I run this, still goes in 5 deep. But if I were to mess up this while loop, I could end up going into an infinite recursion or an infinite loop, right? So now let's say I try it in a way where I can solve this recursively. So now I can say if num is equal to 1, then I wanted to return 1. And that was pretty much the same thing I had here, right? I said while it was greater than 0, then I wanted to continue doing this behavior. But once it turned into 1, I no longer needed it to return anything. I don't need to check for 0 because 0 is the value of 0 and I don't need to account for it. And I would say else I want to return the number plus the sum up to. That's now going to take num minus 1. And that's exactly what I did here. I did I minus equals 1. I'm still calling the same function. The same behavior inside of the function is happening over and over again. But now all I'm doing is subtracting it the next time I call the function. And let's have it take in a second optional parameter with the default of 0. And let's say in here, we'll just increase counter by 1 And then we'll pass counter as well. Let's have it print. Counter. Okay, so now counter is going to be initialized to 0. It's going to be added. I'm going to add 1 into it and then pass it into my next function. So when I run this, I should see 15 and 5. So let's see. So it was more efficient. It was able to do the exact same behavior that I had up here, but it only did it in 4 recursions. It only did this loop 4 times. And we see that because by the time it prints, our print statement tells us exactly how many times this function had to be called over and over again, which was a total of 4 times. And that's recursion. Does anyone have any questions on this? All of our problems this evening will be on recursion, so we'll get plenty of practice and we'll get to see this over and over again. So we'll do them together. We'll solve them without recursion, and then afterwards we'll come back and turn it into a recursion solution.
Can you explain to me where 15 came from? I think I'm getting lost here.
Yeah, of course. So 5 is here, right?
Mm-hmm.
5 is not greater than 1, so 5 goes down here.
So wouldn't that be num would be 5 and then sum up to num, wouldn't that be 5? So wouldn't it be 10?
Right. So this is 5, right? And then num minus 1 is 4, right?
Yes.
Okay, so then it takes in num as 4. It asks, hey, is 4 equal to 1? No, it isn't. Then it's going to return this again. So on the second iteration, turned it into 4. So now it goes into the third iteration. And in the third iteration, it turns it into 3. And then it goes into the fourth iteration, where it turns it into 2. And then lastly, but not least, it goes into the fifth one, where it turns it into 1, right? So this
Okay.
num minus 1 keeps happening over and over again.
Okay, I got you.
Yeah,
Cool.
so then that just turns into 5 plus 4 plus 3 plus 2 plus 1, and then that gives us our 15.
Awesome. Cool. Thank you.
No problem at all.
The first time it happened, so are we still doing num minus 1, which is supposed to be 4, or why is it still 5?
So the original num here is 5,
Yeah.
right? But what's being passed into the function is 4. So when it gets called into the function again, now it's 4. So that's why we get 5 plus 4, which then goes through again and gets 4 plus 3,
Okay.
and so on.
Okay. Gotcha. So this is the plus whatever is the iteration 4, 3, 2, 1. Then the num is just once, correct?
Right, the num is just being altered by 1.
Okay.
Awesome. Okay, great. That's pretty much all we have as far as lesson material goes today. So let's take a 10-minute break and then get back and just start going over the problems for this evening. Awesome. I'll see you all in 10 minutes. All right, welcome back, everyone. Let's start going into the exercises for today. So as previously mentioned, first, let's solve the exercise in a non-recursive way. And then after that, let's solve it with recursion. So we got this pyramid from Replit. Let's fork it. And let's see what we got. Okay, so using recursion, write a function that returns the total number of blocks in a pyramid with a given height. A pyramid looks like this. Okay, so it starts off from 1, 2, 3, 4. Okay, so pyramid rows pass 3. It has 1, 3, 1, 2, 3, 4, 5. So it goes up by 2 every iteration. So how could we do that?
Using square,
Square?
right? Since it goes up by 2, so we can use the square function.
Okay. Is that what you're saying?
Yeah. Or we can also use, I just saw that today actually. We can also use map. Map, then we put square in there. It's gonna I don't know if you've used that before, map.
Map?
So if you have map, if you have return, return, then map, map, then parentheses, then square. No, square is like spelled out.
Oh, square. Okay.
Then comma, then rows. I believe that one.
I don't think so. Yeah, I've never seen this.
Try S maps, not just map. Still no. Huh.
Yeah. So let's see. I do believe you're onto something though. Maybe rows.pow to the power of rows. Yeah, we'll have to look further into that. I was thinking of something more straightforward, maybe iterating and adding 2 each time. What do you guys think?
Yeah, we can do that as well.
Okay, how do we do that?
So if we do the first iteration, then we can find the square of each value after the iteration. So for I in rows, then we can assign the index value of each word and increase it by 2, multiply it by 2.
Okay, so let's see. So you're saying count is equal to 0, and then you're saying for I in rows. So what should I do here? Should I just add it to count?
Could we do a while
Rows
loop,
dot
like while?
Can you say that again, Andrew?
Well, I was gonna say, could we do it like a while loop, like while I is less than the input? So each one of these are squared. So 3 squared is 9, 5. So while I is less than, but I don't know what to times it by.
The rows
squared.
Right.
Yeah.
Okay, what I want to do here. Or are you saying you just wanted to return times rows?
Well, it would have to be because we'd have to iterate through it, right? Or would that maybe that would return? That should return true for each one.
Yeah, technically, so this returns false. So let's see what this is actually doing. Okay, so 3 times 3 times 3. That's 9. I mean, that's 27. So maybe instead of rows, what we want is 2.
Or could we do,
There you go.
oh, there we go. Or if we did rows times rows, would that work too?
Yeah, instead of double square.
Oh, yeah, that would have been the same. The easy way. There you
Yeah,
go.
okay.
Everything's all true.
But is that really the requirement? Because it looks like it's supposed to be like incrementing. It's supposed to be doing what you did earlier, which is like 3, 4, 5, 6. Am I wrong?
Right. So another way of doing this would be like, let's say counter is equal to 1, right? And then for I in, and let's say rows, and I don't want it to start at 1, instead I want it to start at 2. I want it to go up to rows, and
Can you please just print I for a second? I want to see what I returns. Because I've tried something like that, yeah, but I kind of get some weird error, I believe, because row is a single number in a tuple.
oh, sorry, I meant to say range. Thank
I
you.
did, yeah.
Yeah, is that what you meant? So that we could see what I is?
Yeah.
Yeah, so returns 2, 3, and 4. Yeah. And then we could do, I don't know, counter.
Why are we starting at 2, not 1? Don't mind me asking for the range.
Because since counter is already 1, then I'm already accounting for the row of 1.
Okay.
So then I just want to start at the row of 2. Right, so in this case, counter plus or equals counter, which is 1 plus 2, which would be 3, and then we could return. Let's print it and return it. So we see 4, but that's supposed to be 9. Oh, because it's non-inclusive. That's my bad. Okay, so it's still returning the wrong thing. So return to 10 this time. Let's see. So it's 1. It goes through. See, so we see 1, it goes through, it adds 1 plus 2, so that's 3. And that turns it into 7.
What would happen if you did counter plus 1, counter plus equals counter plus 1 instead of 2?
Counter plus 1 instead of 2. I think that would, yeah, let's see. So I return 7. Let's see.
And it returns 31 and 127.
So counter is 1, it goes through. I see where it's messing up. See, because if we run 2, it goes 1 and it does return 4, right? But for the next row, where it's supposed to grab 1, 2, 3, where it's supposed to grab 5, it grabs 6. And that's because I'm saying 4 plus 2. Maybe I should have answer is equal to 1. And then as it goes through this, I could say answer plus or equals, have this be counter, or actually I. Oh. See, so answer is equal to 1 for I in range. So it grabs 2, where counter is 1, and I'm saying answer plus or equals counter plus 2, which should be 1 plus 2. That should be 3, which should return 4. And then on the second one where it's 3, oh, but I'm returning counter, and I'm not increasing counter. I guess this should just be 1. Sorry, I'm not even talking about that. I apologize. Let me try to fix this real quick. And okay. Let's see. Grant answer. So now it's returning 8. So now it's 1 too short. So let's see. Answer is 1. It goes through. I in this case will be 2. I 2 plus 1, that is 3. So then answer will be 4. And then 3 plus 1 will be 4, making answer 9. But I wonder why that's not working. Does anyone see any mistake I may be making? 2 and 3.
If you set answer to 0 and range, just go through the entire row, would that correct it?
Maybe, but then I would have to start answer at 0.
Now we're 1 over.
Maybe you were on to something. Let's see. Nope.
What if it started at 1?
That might be it. Yep, that's it. Okay. Awesome. So it's at 0, starts at 1, 1 plus. I wonder if it will work for the other two as well. Let's see. Yeah, so these other two return false. Okay. Let's see. Let's see if we can solve this recursively instead. It might be easier that way. So we were to follow the same example that we saw in the summing, right? So we know that the first stopper that we need to account for is if rows is 1. So let's say if rows is equal to 1, then I just want to return 1. So now
double equal.
Thank you. Let's go into our else statement. In our else statement, we want to return the pyramid again. So using recursion, write a function that returns a total number of blocks on your pyramid with a given height and pyramid that looks like this.
I think rows first. Rows, then plus, then the pyramid.
Rows and what?
I thought earlier we did we passed the parameter first, then plus the other parameter minus one. But go ahead, right? That's it.
Oh, you're saying to put rows first. Rows and then add -1.
Yeah.
Okay, well, let's see what that returns. Oh, well, probably want to return that, right? So we know this one's supposed to be equal to 9, so let's see what it does. So return 6. So that returns 6, but I don't think we're actually answering the question. So let's see, we're using recursion. Write a function that returns the total number of blocks in a pyramid with a given height. A pyramid looks like this. So it gives us each pyramid, and for each row, it's adding the value of 2. All right, so we see 1, 2, 3, and 4, and so on.
So if the row is 3, then I'm not sure if then it should be 5, not 9. It's adding 2. It's incrementing by 2.
Right.
I don't know if the answers are right. Because it looks like the requirement is totally different from what the answer is saying.
Yeah, so 3 plus 1 is 4. And then when you add 5, that puts it at 9.
Plus 3 or 5 plus what?
So 3 plus 1 is 4, and then row 3 is 5. So when you add 5 plus 4, it gives you 9. So that's what it's asking. Say again?
Yeah, it's adding prior numbers. Okay.
Yeah. So now let's see. How could we do this?
Why return rows plus pyramid rows minus 1?
Yeah, we probably don't need that, huh? Is that what you're saying, Seki?
Yeah, I just don't understand.
Yeah,
what
we
does that do?
let's see. So if rows is equal to 1, we want to return 1. Else we want to return okay. So let's do a counter. And let's make that equal to 0. And what we want to return would be technically the counter, right? But the counter should always be, is it 1 more or 2 more?
2 more.
No.
I just posted something that sort of worked. It got back the right numbers at least. But I don't know if it was answering the question, how it's being asked.
Yeah, because I'm trying, so we could figure it out rather simply, right? But if we try to implement recursion, that's where it gets tricky.
Yeah, true.
Yeah, but your answer definitely works. Let's see. So we got a counter, and at 4, it's supposed to be 3. Oh, so it's just row minus 1. Oh. Okay. So maybe we should do counter plus that. And then else we could return rows let's see, current let's say we have the pyramid and then we want to pass where rows -1 and then we want the counter to be equal to counter times 2 minus 1. Right, because counter times 2, so in this case 4, and then 4 minus 1, that's 7. And that's how many we have here, right? 1, 2, 3, 4, 5, 6, 7. Okay, so 7 would go through. Then rows would then turn into 3. And they'll get passed on. So now we got 3. And now 3, where counter times 2 minus 1. So 6 minus 1, that's that's 5, which is what we wanted. We want 5. Then it goes through a third time, or yeah, third time, which would be row 2. So 2 times 2, that's 4 minus 1. So that's 3. And I think we want this to be plus equals convert a number or string integer or return. Okay, so let's take that out. And sorry, this is supposed to be rows, not counter. So let's take that out. Let's put that there. And let's put counter in there. Okay. There it is. And let me talk a little bit better through this. So counter is a second variable that we created where we're going to be passing pretty much the second value that we need, right? And the reason why we're passing this is because in the end, if row is 1, then I just want to know everything before it plus 1. Right? So otherwise, for example, in row 4, what it's going to take in is it's going to take in that it's a row 4. It's going to realize, so counter currently is 0, and I want to add whatever row 4 is. So 4 times 2, that's going to be 8, minus 1, that's 7, which is how many blocks they're supposed to be. And now that counter is 7, I want to pass it to the next algorithm at the row of 3. So now I got row of 3 and 7. As it goes into row 3, it realizes that it is not 1. So then it takes in 3 times 3, which is 6, subtracts 1, which gives me 5. And 5 plus 7, which was the original value, is now 12. Oh, I'm sorry. I'm supposed to be going from 3. My apologies. So it goes 3. 3 times 2 is 6, minus 1 is 5. So it sets the original at 5. Then it goes down to a row of 2. At the row of 2, it goes 2 times 2 is 4. Minus 1 gives me 3. So 3 plus 5, that puts me at 8. And then it hits my if statement where it's 1. And all I do is add 8 plus 1 to give me 9. And if I uncomment these two.
I'm sorry. What is counter? Is counter how many blocks?
Yeah, I should rename that. Let's see. Total blocks. Yeah, so we start off where total blocks is 0. And actually, let's print that. Print rows times 2 minus 1. And then let's print total blocks. Ooh, that's gonna be quite a bit if I run it like that. Okay, so let's start off with 9. So we see 9, right? The first row that comes through, and let's actually print the row as well. Okay, so we see the first time it comes through, it's at the value of 3. So 3 is not 1, so it goes into this print statement. And what it does here is it says 3 times 2, that's 6 minus 1, so that's 5. And that's how many blocks are supposed to be on row 3, right? Then it goes total blocks. So my total blocks is currently 0, but I'm gonna add what rows times 2 minus 1, or how many blocks are supposed to be in that row. And when I print it, I see the number of 5. So now it goes into my second iteration, where the rows is 2. On row 2, the total number of blocks is 3. And when I print the total blocks, meaning 5 plus 3, I see 8. Then when it goes finally into row number 1, it just returns total blocks plus 1, which gives me 9. All right, and then I could watch it on the next one. So I run it again. Goes through, we see 5 and 9. So here's 5 and here's 9. On the next row, or on the total blocks, we see 9. On the next row, where the row is 4, there's only supposed to be 7 of them. So it adds 9 plus 7 and gives me 16. On row 3, there's supposed to be 5. So it adds 16 plus 5, which gives me 21. On row 2, there's 3. So 21 plus 3 gives me 24. And then I add my 1 for row 1, and it gives me 25.
Quick question on that.
Uh-huh.
So on line 16, where it's doing the iteration,
Yes.
so we have from line 15, we have 9, right? Or am I wrong? Or is it 5? Yeah, 5 times 2, 10 minus 1, 9. So from line 15, we have 9.
The first time we have the row 5 and 9 blocks, yes.
Yeah, so then when it gets to 16, so we saying 9 times 2, 18 minus 1, 17.
No, we're saying rows times
First
2.
time.
Can you hear me, Kim?
Yeah.
Yeah, we're saying rows times 2 minus 1. So this is 9 still, but I'm adding it to 0.
Can you explain what does pyramid rows minus 1 to total blocks mean?
So the pyramid is the function. Rows is the number of rows there is in the pyramid. And then total blocks is how many blocks are inside the pyramid. So in the case where the pyramid is 3 rows, there should be 9 blocks inside of the pyramid.
Okay, then why do you return rows minus 1?
So I multiply rows.
Line 18.
Say again?
I just don't understand line 18.
Okay, so line 18. So rows is 3 right now, right? And when I grab how many blocks there is in 3, I say, hey, there's rows times 2, which is 3 times 2 minus 1, 5. So there's 5 blocks on line 3, right?
Yes, yes.
So now that I know there's 5 blocks in line 3, I need to go to the next row. So I call my same function, where rows is 2 now, and total blocks is 5. Right? So we see 3 and 5, and on my next block, we see 2, and then 3 is how many blocks are on my current row. And I'm going to add that to total blocks so that I have 8. And then I pass that to my row of 1, where 8 plus 1 is now 9. Does that make sense, Seki?
I still don't know what's rows minus 1 mean.
Yeah.
What does rows minus 1 mean?
I'm just subtracting 1 row, if that makes sense. Let me see. Okay, so here I have row 1. Here I have row 2. I have row 3. And I have row 4. So now I figured out that in each row, the number of blocks in there is the equivalent of saying row times 2 minus 1. Right? So if I know this, how many blocks are in row 4?
7.
Yeah. Awesome. So how many blocks are in row 3?
5.
Okay. What about row 2? This for anyone. How many rows are supposed to be in row 2?
3.
Yeah, so 3. And then lastly, in row 1, we have 1. Right? So this is what we know. And let's grab our function really quick. Oh, hello. Okay, so it doesn't look the best because of the way it's formatted. But we're gonna work with what we got here. All right, can everybody see these clearly?
Yes.
Awesome. So now let's call our pyramid function.
Real quick though.
Uh-huh.
So if the question was to like say like right now we have 4 blocks. So if one of the parameters we're passing in is 4, it should have been, the total should have been 16.
I don't know off the top of my head, actually. Let me see. 1.
I just added 7 plus 5 plus 3 plus 1.
Yes, so then it should have been 16. Yes.
Okay.
Okay. So we have pyramid of 4. right? And in this function, we have total blocks, which we also assume, or we give it a value of 0 without explicitly having to pass it into our function call, right? And as it goes through, so the first row that it goes through is row 4. And in row 4, we already determined that there's 7 blocks in there, right? So this is the original call. And when it gets spat back out, what gets returned is pyramid rows 2, 1, rows minus 1 with the total blocks. So in this case, say again.
That's row 3 with total blocks.
Not with 2 blocks, with 7, right? Because that's how much we discovered was in here. Does that make sense, Seki?
Isn't the row of 4 minus 1, 3. Row block 7, yes.
Okay, awesome. Okay, so now we see pyramid of 3 with 7, right? And now that pyramid of 3 with 7 moves on to row 3. Okay, and then when it comes out from row 3, what does it come out of?
5.
All right, so we're calling the pyramid, right? But now instead, total blocks here in this line, I'm not making total blocks just equal to the new value, right? So now I have 7, and how many blocks are in here? 5, right?
Fine,
And in this line, what I'm doing is I'm saying, okay, well now total blocks is equal to its prior value plus the number of blocks in this row. So what's supposed to come out, or what's my next function call here? So rows minus 1 is 2, right?
13.
Yeah, perfect. So it'll be 12 because we got 7 plus 5.
Oh.
Right. So now we got that. And now it goes into row 2. And when it goes into row 2, what does it spit out? We got pyramid again. What's the new number of rows?
2.
It's 1 because we're going rows minus 1, right? So it was rows, which was 2. And now we're subtracting 1, which turns it to 1. And then what's the new value of the total blocks? Right, so we had 12 before, and we see there's 3 new ones here. So what would it be here?
15.
Yeah, perfect. So we turn into 15. And then finally, it goes into row 1, where it meets our condition of if rows is equal to 1. So it just returns 15 minus 1. So once it's here, what does it spit out?
15 minus 1, 14.
Yeah, so 15 plus 1, right? Which is 16. I think I said minus. That's my fault. Yeah, which just spits out 16. And that turns into our value, our final value that we return, right? So that's kind of how recursion works. So this was our original call where we call 4. It went in, did 4. It accounted for all the blocks inside of 4, which was 7. And then it created the pass for the next row that I wanted to go into. So the next row I want to go into is 3. So then I went up to row 3. It counted 5. So now I have 12 blocks. Now I want to go up to row 2. I go up to row 2. I have 3 new blocks. So now I have 15. And my last row, I want to go up to row 1. So I go up to row 1. I meet my condition of if rows is equal to 1. And all I need to return is the number of blocks plus 1. So I return 15 plus 1.
Can you
Go ahead, Akeem.
can you hear me? Can you please bring the function, the code block down there? Can you please bring it up a little bit and let's walk that through logically from the step, just like you explained?
Oh, you want me to walk through this as I'm going through this?
Yeah.
Yeah.
The picture is quite understandable how you move from 4 to 3 with the minus and then and the number of rows in there. So, but with the code block, I think that would make more sense now.
Awesome. Yeah, so let's take off these print statements here and here, because that just puts in some extra noise, right? And let's just concentrate on the else block first. So my initial call for the pyramid is 4. So I bring in 4, and my total blocks is already initialized as the value of 0. It's not going to go into my if statement, so it'll go straight into my else. So now I'll say total blocks is equal to rows times 2 minus 1, which is what we defined here, right? And rows times 2 minus 1 is how many blocks are inside of each row. Does that make sense so far?
Yep. So 4 times 2, 8 minus 1, 7. So, yep.
Yeah. Perfect. So then it goes through. And what I was doing on this portion where the return statement comes in is I'm calling the pyramid function again, but I'm subtracting 1 from the total number of rows. So here we see 4.
So I can go to the next one. Okay.
Right. And then we account for the number of blocks that was inside of row 4, which is 7. So now we go into row 3. And the same thing happens. So I say the total blocks is equal to plus equals, not equal to. It's plus or equals to rows plus 2 minus 1, which again, we already determined is 5. And total blocks is no longer 0 in this case. Total blocks is now 7. So now 7 plus 5 gives me 12.
Where is that happening? Where is that 7 plus 5 happening in the code?
Right here.
So the rows we are bringing in the second time for the third row, what is that value? Are we bringing in 7 or are we bringing in 3?
Rows is 3. Total blocks is 7.
Okay, so the value for total block, where it's like you're saying 7 plus or equals to 3 times 2 minus 1.
Right. Which in this case would be 5, right?
Okay.
And that's why we see pyramid 2 and 12.
Huh. Got it.
Yeah. So then when it goes into the second row, we subtract 1 from the row. So 2 minus 1, that's going to be 1. And then we already had 12, but now there's 3 new blocks in there that I'm adding in there. So the new function is pyramid 1, 15. And then finally, rows is 1, so my if statement comes true. And because my if statement comes true, all I return is 15 plus 1, giving me 16. Did that clarify things a little better, everyone?
Yes.
Okay, that's great. Yeah, I know recursion's hard to understand, especially.
Can you please pull up the slide if you don't mind, please? The slides where we have the recursion
Slide for recursion. I think I have it.
The yeah. So in the code, we have in the else statement, since we are having a +1 recursion, so we having return 4 plus then some then -1. So since we are the pyramid in the pyramid example, since we are going 2-step, so me my small thinking, I'll think instead of doing 4 minus 1 to just be 4 minus 2. Is that assumption wrong?
Are you talking about for this problem or the one we're working on?
For the one we're working, since we are going 2 steps, so 1 plus 2 then plus 2. So I was thinking instead of him being -1 plus -2, so it should just be row plus whatever function we're passing, then the row -2.
Okay, I see. So you're saying as if we were to start from 1 and move up to 4, right?
No. So since
Okay.
we have 1 plus 2, then we have 3. Then 3 plus 2, we have 5. 5 plus 2, we have 7. So it looks like we are incrementing by 2 instead of by 1. Like, just like the other previous example, they were incrementing by 1. So like 5, 4, 3, 2, 1. But here we are doing 2 steps. 7, 5, 7, 5, 3, 1. So that's how I'm thinking. Instead of it being -1, should be -2.
-1 should be okay. I see what you're saying now. So you
From that slide, but it's okay. That's my thinking from the slide. It should just look that way, but with the whole explanation, it kind of makes sense, but it's still a little complicated, though.
Yeah. So if we subtracted 2, we would be subtracting too much. This rows times 2 minus 1 seems to give us the numbers that we need. I'm not sure if there's a different formula for us to figure this out.
Yeah.
And especially with the limited information that we got here, right? Because this is all that we were actually provided. And we know that the original number that it provides us will always be the biggest number of rows. Right? So we need to work from bottom to top of the pyramid. Okay, that one was a rough one, and it took us a while. Let's push to the next one. Let's see, reverse word with recursion. All right, so using recursion and without creating any additional variables, create a function that returns the reverse of an inputted string. Okay. So now we're supposed to use recursion to do this. So how could we do that? Because obviously, after learning what we learned earlier today when Akeem was showing us this code, we could just return word and then make it -1. And if we run this, it should come out true, right? So technically that should work, but it doesn't use recursion. So now let's say that I wanted to use recursion. What is it that's going on here? So I'm iterating through my word and I'm turning it around. So how could I do that? We could probably slice it, right? And then just add the very last number or the very last digit, sorry, very last index of our string as we move along. Any ideas?
Using recursion, you might have to get the index of each word and turn it around or something.
Right, so we could get the very last letter from the word, right? And then using recursion on the next one, we could maybe pass in a slice of the word and then just add it continuously as we work through. Kind of how the lesson shows us. So let's see, let's copy this function. Oh. So we got we got our function, so let's do that real quick. If it's equal to 1, then return that. Otherwise, return everything else. Okay, so if word is equal to 1, return word, else return word plus reverse word. Okay, so this same principle should apply. So how could we do this? First of all, I gotta, how do I check if a string has the value of 1? Right? Or if it's, because I'm asking it if it's 1. How could I make this make sense?
If the length of the string is 1.
Yeah, that's perfect. So let's check if the length of it is 1. Right? Then I could return the word itself. What about in this else statement? So in this else statement, I'm saying return word plus reverse word. So maybe word shouldn't just be word, right? Maybe I want the last letter. That way I could reverse it. So how could I get the last letter of a string?
Word minus 1 using
Yeah, the index.
Perfect. So index -1. But now, say again.
Slice.
Perfect. So how do I slice it?
Colon minus 1.
Yeah, colon -1. Perfect. So then I'll get H and I'll pass in LO or right, LO into this. And then instead of H, I'll have E and low will get passed in and so on. So let's see what it does. If I run it, we get true for both statements. And that right there was using recursion. This was a lot easier than the pyramid one. I'm not gonna lie. We should have this one first before jumping into the pyramid, huh? Awesome.
Can I share something real quick?
Yeah, of course.
I'm sorry, I'm gonna take us back to that pyramid again. So, but I just needed someone, to explain what's going on.
I'm sorry, could you say that again?
Let me show you. So, just looking at this, what am I doing wrong?
Oh, you're sharing your screen? Was I not
you
sharing?
don't have my screen?
I could see your screen, but I'm wondering, am I sharing my screen still?
No, I'm sharing now. I don't know if you're.
Oh. Was I sharing my screen or okay.
You were sharing your screen.
Okay, awesome. Okay, go ahead. So if pyramid rows is equal to 2, we wanted 1.
The thing is giving me the right value with the minus. So I'm not sure if but it's continuous loop. It's not stopping.
It's probably because of line 16 when you're returning rows -2. right? Because rows never is equal to 2, because 3 minus 2 is 1. And then 1 minus 2 is -1. And then -3 and so on. So it never equals 2 on line 12. So maybe check if rows is less than 2. Less than or equal to 2. Oh, that's greater than or equal. Oh, rows is less than or equal to 2. Yeah, there you go.
Why would you return 2?
Because we are incrementing by 2 instead of 1. With the answer I gave, the answer what we have earlier, it kind of was just that it was too it was crazy. It was doing what it's supposed to be doing. It was having 3 plus 2, 1 plus 2, 3, 5, 7, 9. It was going plus 2 increment like that. It's just that it's minus. So
yeah, this approach would work if we were working from the bottom, I mean from the top down, if we were working from row 1 to row 4. But that's not the case. They're telling us the total number of rows, so we have to work from the bottom up.
should this be plus?
No. Maybe, yeah, you could try doing plus, and then instead of I don't think that would work either. Yeah, because you see you get 9, but how would you stop it?
Yeah, don't stop it.
Right.
Going. All right. Look forward to it. Thank you. I'll stop sharing.
No problem at all. You just yanked that away from me. All right. Oh, okay. Yeah, we were working on this one. Awesome. Does anyone have any questions on the reverse word and how this worked?
I don't think I understood recursion well. Can you explain again about what does recursion do?
Yeah, so recursion is basically calling the function itself. So it's calling its own self. And let me see if I could find a better way of doing this. So let's say that I had a function of, oh, sorry, the menu, right? And this menu doesn't take any arguments, but it returns many things. So let's say it return. So if forgot how to take an input in Python. Let's see.
Input.
Oh, yeah, perfect. Okay, so let's say choice is equal to input choose between 1 through 6. If choice is equal to 6, then I wanted to return bye-bye. Else, return choice. So now let's say I go and I print menu. So it tells me, hey, pick a choice between 1 through 6. Let's say I pick 1 and I press enter. Okay. Asks me for my input again. Or it didn't ask me for my input again. Interesting. Oh, because I put return choice when I meant to do return menu. There you go. Okay, so return 1 through 6. I could put 1. I could put a bunch of gibberish. And I'm just stuck because it's calling itself, right? It's going back to its original function call and restarting the function. All right. But the moment I put 6, oh. But the moment I place 6 in here, now it says bye-bye because my stopping condition was met, right? So now here's my stopping condition in our reverse word method. In our reverse word method, what I'm doing is I'm saying my stopping condition is if the length of word is 1. Otherwise, I want you to call yourself and just grab word -1. So let's see. Boom. Right, so when I run this, oh, I should probably bring this back as well. My apologies. So when I run this, we see that -1, word -1, if we see 0, we see L, we see another L, we see an H. So it's doing everything forwards, but it's actually printing it backwards, right? And I'm actually surprised that this is not showing me H. Oh, right, because it's grabbing from the very last index. I'm so sorry. So the first one that it grabs O, right? So we see O being printed here. And all I'm saying is I'm adding it to the rest of the word. So now I'm taking O and I'm calling the same function, but instead of passing hello, I'm passing in hell, right? When it passes in hell, it grabs the L, and now it just passes in hell with 1 L. So it grabs the second L. The next time this gets triggered, it only passes in he. And the last time it gets triggered, it only passes in the letter H. And then at that point, the length of word is equal to 1, so it just returns the letter H. And after that, the addition happens, and all I'm doing is adding so I'm adding O plus L plus L plus E plus H. That's what this function right here is doing. And the purpose of recursion is just to, instead of using a loop to be able to do these algorithms, you're just calling the function itself to avoid using a loop. Does that kind of make sense, Seki?
Kinda.
Yeah, emphasis on the kinda, right? Okay. Yeah, it's definitely going to take some practice, and it's going to take some looking around at more problems for us to be able to get this down. But I recommend the problems that you guys have had done so far. Start going back into them, especially the ones that you thought were easy, and see if there's a way to solve them with recursion. If some of them are just a flat out 1-line return statement, then don't bother with it. But for example, the employee data, that one could definitely be solved with recursion. So yeah, let's move on to our next one. And actually, before we move on to our next one, we've been going for quite a while. So let's take a 12-minute break, and let's come back at 8 o'clock and go into our next problem. See you guys in 12 minutes. All right, welcome back, everyone. Let's go over the greatest common denominator exercise using recursion in Python. Okay, so let's see. We got Euclid's algorithm for finding the greatest common denominator, GCD, for two integers is GCD AB is equal to B if B is evenly divided by GCD AB is evenly divided by a GCD. That doesn't make any sense. Where GCDB, remainder of AB, i.e. A percentage B otherwise. Write a function using recursion to implement Euclid's algorithm and return the greatest common. Okay, so let's look up Euclid's algorithm because I don't know about you guys, but I was not able to understand that. Let's see, Euclid's algorithm for finding GCD, a greatest common denominator, AB, is follows. If A is equal to 0, then GCD A, comma B is equal to B. Since GCD greatest common denominator is 0, B is equal to B, and we can stop. If B is equal to 0, then is equal to A, since GCD, and we can stop.
Just reading that, just kind of.
Say again?
Just reading the whole line right there, just kind of,
Yeah.
doesn't make a lot of sense.
Euclid's algorithm, okay. Part A in quotation remainder form.
I feel like deciphering this question is going to take longer than the actual code.
Yeah, trying to figure out what's going on. Well, maybe if we look at the answers, we can figure out what it's saying. Okay, so I guess it's saying if A is evenly divided by B, then the answer is B. And same thing vice versa. But otherwise, if there's a remainder, if there's a remainder, there's supposed to be something. Oh, if there's a remainder. Say again?
I'm supposed to divide A by B. Is that what it's saying?
Well, let's try that.
If there is a remainder, are we supposed to divide the remainder?
Let's see. Print num1 if num1 modulo num2 is equal to 0. Else num2. And let's concentrate on the first two. Okay, so we see 32 and 18. Print num1 if num1 modulo. Oh, I got these backwards. So this one's supposed to be 2, and this one's supposed to be 1. There you go. Okay, so now we get 16 and 6, right? So we see num2 because num2 modulo because num2 modulo num1 is equal to 0. Oh no, I had that even more backwards. I'm sorry. This is supposed to be num1. This one's supposed to be 2. And this is 2. And this one's 1. Okay. Go ahead, Akeem. Were you trying to say something? Okay, awesome. So this is at least telling us if one of them is the remainder, right? And it's equal to 1. So I guess we could just make that into an if statement as the stopper. So let's say if num1 modulo num2 is equal to 0, or num2 modulo num1 is equal to 0, then I want it to return. And let's say num1 if num1 is less than num2, else num2. And let's print this statement as well. Okay, so now I run this. Okay, so we see 16 and 6, and that's what it's returning. So that's the first portion of it. If it can be evenly divided, then it's equal to that number. All right. And now the second portion of it. So let's try to figure out this one. So then else, let's say, well, we would want to do the working number, right? We would want the greatest number to be divided by the smaller number. So I guess first we need to find out which one's the smallest and which one's the biggest. So let's do this. Say small is equal to.
Can I ask a question?
Yeah, of course.
I don't understand line 8. Why
Oh.
do you return num if num1 is smaller than num2?
Yeah, of course. So let's do that. So I'm basically just writing an if and else statement. So I'm saying if num1 is less than num2, then return num1. Else return num2. So this is saying this condition in the middle, that's our if statement, right? So if num1 is less than num2. So if that condition is true, my left argument is what I would like to return if this is true.
Yes.
And then my right argument is if it's false. So in line 7, I'm making sure that the running the modulo of one of them is at least returning 0, right? Not both of them, but at least one of them. Because we know 6 modulo 18 is not 0, but I know that 18 modulo 6 is 0, right? And same thing with 32. 16 modulo 32 is not 0, but 32 modulo 16 is 0. And now because I have that, I need to return.
Okay.
What's up?
No,
I think you're breaking up, Akeem. Could you say that one more time?
I was wondering what was going on line 7, but you explained that means, so please continue.
Okay, awesome. Yeah, so now that I've determined that at least one of the doing a modulo of at least one of the combinations from these two numbers returns 0, then I need to return the smaller one of the two, right? That way I could get the greatest common denominator. In this case, 32 and 16, it's not possible for 32 to be the greatest common denominator, so it has to be the smallest number, which is 16. And that's what this is doing on line 8. Does that make sense?
Yeah, I just didn't understand the algorithm, the UCLD.
Oh, the syntax?
Yeah.
Okay. Yeah. All right, so now we got else. And now we want to return this. And I think this is where the recursion is supposed to come in. Right? Because we want to figure out which one's the greatest number. After that, we want to, I guess, subtract the smaller number. And then run the same function. No, that doesn't make any sense. I think you guys are right. I think we would spend a considerable amount of time trying to figure out how to make this work. I may have to look up the directions on this and get you guys a better set of directions for this, because this right here is not very helpful. And then once I have that, then we could re-attack this problem more efficiently. I apologize, everyone, but I'll make sure I'll keep a note of this and I'll email it out to everyone, or I'll just put it in the intro to coding channel. For the time being, does anyone have any questions over what we've done here before we move on to the Truthy and Falsey exercise? All right, let's move on to Truthy and Falsey then. Okay, let's fork it. Okay, so Truthy and Falsey. Write a function that takes in any data type of any length and returns whether or not it's a Truthy or Falsey statement. Okay, the following values are always Falsey, and everything in here is Truthy. And this is actually wrong, so let's move that. Okay. Awesome. So this is supposed to take in something and tell me if it's false or true. The false is Falsey value. The number 0 is the empty string. The null is Falsey. Okay. Okay, well, this one is supposed to be false, so let's fix that. Okay, so it looks like there's a couple of if and else statements that we need to account for. So the first thing that it checks for is data types, right? So I'll let you guys navigate me through this, and then I'll just drive as far as the code editing session. So how do we solve this?
False. So we can use the f string to pass in the string. Then with the if statement, if false, fa. Then semicolon. Then we can use the print or return a value f string. Yeah, you can just copy the false is a falsy value factor in there.
Oh,
You can put data, right, in there on that string.
Let's do data. Okay, so data is a Falsey value. Okay. Is this what we want here?
I think you need to define what type is the data first.
Okay, so that's awesome. So do we want that here in this if statement, or where do we want that?
And pass a variable to hold the string.
So let's concentrate on line 26 first. What do you mean by a variable to own the string? Are you talking about this string?
With the false data to convert it to
Well, I don't think we want to convert it, right? Because it looks like later when it turns into a string, it tells you that it's an empty string. So it looks like we have to check if it's first the data type and then if it's true or false.
Okay, to check the data type, you can use a or statement in the if statement.
Okay.
So we can use the type or just normal string to check that, if that's what you're saying.
Okay, so let's do type. Do I want to check false or do I want to check data?
Should be data.
So if type data is what?
Number. Integer.
Empty string.
So in this case, we're just checking for line 26 where it would be false, right? Data is false. So what type of data structure is false?
Boolean.
Could you,
0.
Okay. So if type of data is equal to Boolean and data is what?
Empty string.
So we're not taking an empty string here. We're just taking in false.
Okay.
Right? And I'm telling it that it's a falsy value. So I also want to make sure that data is false, right?
so you just do equals false, right?
Yeah.
You do that like not true? Like the equal and the
Yeah, I could also do
Okay.
not true. Yeah. Okay, so this is returning false. So let's see what this looks like. Okay, so it's just returning false, meaning that it's not going in there.
Why is it not printed?
Because it's not going inside of our if statement. There you go.
False, let's say false.
Do we have to do the data type, or if we just do if data is false, return that F string?
Well, let's see. So if I uncomment this one where it's an empty string, right? And I run it, it returns false.
Well,
Let's comment this part out.
well, the output is not the same anyways.
Right. Because now it's telling me, hey, this is specifically an empty string. And that's why it's falsy.
Yeah.
Okay, well, what about in this one? What if this is Truthy? What type of conditional statement do I need here?
Else return.
Say again?
So if the parameter is true, is that what you're saying?
Yeah, so if I pass true, how do I get both of these to pass?
Yeah, so in the case statement else.
Do I just L?
LF.
Okay, so let's do an elif. What's in the elif?
Type data equals we can just do an integer.
One.
No, right?
Okay.
Because
But we're
false is an equal to 1.
True.
Yeah, we just want to check if it's a Boolean.
Okay.
Say again. Was that you, Seki?
Yeah.
What did you say?
I said what you just typed. That is a Falsy.
Oh, I see. Yeah. So now if we run both of these should return true.
I do have a question though.
Uh-huh.
So in the if, what if that is just else, then return line 26? It won't work.
Well, let's try it out. Let's see.
No, don't put 31. Just
Well, that's the point, that it's got to be able to pass all of these cases, right? So if I comment it out and I just make it else, and I also comment out this, then yeah, that would pass. I would get both trues. But then as soon as I introduce this case, it would fail.
yet. Now, I see your point. We're considering other parameters, so that makes sense.
Awesome. Okay, so now let's move on to the next one, which is the number. So how do I check if a number is truly or false?
Then we start with if then again.
Mhm.
So to check that number,
Integer, int,
Type data is what?
int.
Is integer? Okay.
and
Data equals
data equals 0.
Let's just check and data, right? Because if data is false, then it'll come out falsy, right? But let's make it clear. Yeah, is equal to false. Okay, then what?
then return back.
So let's return this F string here.
I'll return the number of F, the number data.
Awesome. Yeah, let's check that.
Quick question.
Go ahead.
So on line 27, when we have and data equals false,
Mm-hmm.
I'm just supposed to be passing the actual value. The value is 0. Yeah. Okay. All right, we can move on.
Okay. So let's check if it's gonna come out truly. So for this test case where we got the number 1, come back false. How to make it come back true?
If again. It's gonna be type of int. And the data equals true. So we return the string, the number or data.
Nice. All right. So now we're into string. How do we go with string?
That's a falsy. So if type of string. Data
Of data, okay.
equals str. And data equals false. Return f string. The falsy should be data.
Okay, let's try it out. Turning false. Are you sure this is supposed to be data?
Oh, data is, oh, that should be just false again.
Yeah. Ooh, that still failed. I wonder why. Oh,
Is false.
Interesting. Okay, so it's not going into our if statement in here. So how do we make it go into our if statement?
Or
So let's see, let's print type of data. Let's see what that gives us. Okay, so it is a string object, just like we're asking here. So that part is being true. So I wonder what happens if we try turning it into a Boolean. Okay, so it does return false. So I wonder what happens if we do data is equal to false. So this should return true now. But when we run it, we see it returns false. So this isn't working. Asking if data is equal to false is not working. So how do I check it's an empty string?
just normal blank.
Okay. So I grab the length. And what do I make it equal to?
Cost to 0.
Yeah, 0, because I'm making sure that it's empty, right? Awesome. Now we see that print string and we see that it's coming back true. Okay, great. So now let's move on to the next one. So what about if it's none? Yeah.
Of if is it gonna be type Boolean?
Let's check. Let's do it without it first and see what happens. Let's see, let's print type data. Let's see what type it is. It's a none type. So maybe I could just check if it's none, and if it is, then return that string, right?
With none? With none?
elif none.
They did that type none actually. That's the question.
Say again.
Is there a data type called none?
Yeah, it's a none type.
Yeah, that's interesting.
Yeah. Seki, I think you were telling me the answer, right?
Yeah.
Uh-huh. So elif none what?
Print none is a Falsy value.
Right, but I want to make sure that's equal to data, right?
Oh, data. Yeah.
None is a Falsy value. Oh. Okay, nice.
So what we did in line 31. So why don't we do the same in line 31? What we did in line 32, sorry. What we did in line 33. Line 33, why don't you do that in line 31? Instead of checking twice, why don't you just check else if type data equals string? Is there any reason for the len checking for len equals 0 again?
Yeah, so what if I have this and now it's supposed to be Truthy? Right? It's not gonna work. It's gonna return false now. And even if I were to comment out everything, returns false, right? And in this case, this is where I would want to grab this elif statement, bring it down, and here I would want to check that it's greater than 0. And I'm just going to say non-empty. And now it's going to come out true, right? So that's the reasoning behind the second check, is to ensure that so the first check is to ensure the data type, because these could have the individual data type and they could also be true. None, its data type automatically defaults to false. And there's no other way, there's no possibility that none types could be Truthy, so there's no need for a second check. Does that answer your question?
Yes, sir. Thank you.
Of course. Okay, so now we got dictionaries. So how do I check for a dictionary?
Oh, wow. So we want to use the key. Select the value. Okay.
I don't necessarily want to grab this. I just want to check the entire dictionary. Right? So for example, let's say print data, and let's print Boolean data. So we see false, its type is false, blah, blah, blah. Okay, so here's where we want to be, right? So it prints data, which is a dictionary. We see that its Boolean value is true, but then we get that false because we're not returning anything yet. So what do we do? How do we get true? How do we evaluate if a dictionary is true?
We can do the is value and check if it's a Boolean or not.
Yeah, so let's check. So first let's check the data type, right? So what type are we looking for here?
Boolean.
So we're actually looking for a
Dictionary,
right? And now you're saying if data is equal to a Boolean. So what Boolean are we looking for here? Say again?
True.
Yeah, true. And now we could return true. Because that's all it's want us to return, right? So now we run that, we get true. And let's say I had a scenario where it was empty.
I have a question.
Yeah, go ahead.
Don't you have to put the value, because true is the value of the dictionary?
So true is a value inside of the dictionary, but that's not what this question is asking. The question isn't asking if there's a true value inside of the dictionary. The question is asking if the data type of dictionary is true, or if it's falsy. Does that answer your question, Seki?
Yes.
Okay. Yeah, so like in this example, this should be false, right? Because we know that an empty dictionary is supposed to return false. So maybe we could make a default statement where else will be false.
Quick question.
Uh-huh.
So in line 51, where we have is truly true. So what if there the value we have there, it's like, let's say the name of a person, or a number. I'm not talking about equals to. No, not equals to. The value, the is truly line 51 is truly is the key, then the value is true. So what if that true is like a name of a person or a number? How do you check that?
Well, it doesn't. Again, it's not asking if a key or a value in the dictionary is true. It's asking if the dictionary itself is true.
Okay.
Yeah. So
how do you make a dictionary false?
So that's fine.
That's what I said.
Okay. Yeah. So let's check it now. Let's check what it is. So print type data. And let's comment all of this out. Let's save it and let's run. Okay, so it's a class dictionary. So now let's try to turn it into a Boolean. Let's see what it does. Okay, so it's false. So it goes into all these ifs, and a dictionary that's empty, meaning that it doesn't have any contents, is false. So we see the print being false, and then we see our test coming back true. Does that answer your question, Seki?
Yes.
So now let's run all of them, ensure we're still in trues. Okay, we're still good. And now let's move on to an empty list. So an empty list is supposed to be falsy. So what if it was truthy, right? Let's check. Let's say I had one. Say I had one in there. And I wanted it to return true instead. So how do I check that?
If data type of data is list equals list and length is 0.
Did you say 0? Okay.
Then return true.
Okay, so this is almost there, right? But if I run this is still going to come back false. And that's because I'm checking if len of data is 0.
Yeah, not equal 0.
Yeah, it must.
Wouldn't it be greater or equal than to 1?
Yeah, so we can make it greater or equal to 1, or we could make it greater than 0. And now if we run it, should come back true. Awesome. And then this last test case. So this last test case is passing a string of 0. And it's supposed to come back true. Can somebody tell me why?
Because there's something in the string.
Yeah, because it's not an empty string, right? It has nothing to do with the fact that there's a 0 in there. It's just the fact that it's not an empty string. So let me see. So type string and len of data is greater than 0. Why? Oh, because it's just expecting true. That's not well constructed. Let's change that real quick. It's wanting us to treat 0 as an individual thing when it's not needed. So just to give you guys a little bit of background, in JavaScript, if you run something like is 0 equal to 0, as in the string 0 equal to the number 0, it will actually come back true. But in Python, since Python's a little bit stricter, that will return false. And I believe that's the reason why this has that special edge case where it would want you to handle 0 on its own. But for us in Python, we wouldn't need to do that. But that is our Truthy and Falsey exercises. Awesome. Does anyone have any questions over Truthy and Falsey in Python? No questions. All right, we're moving fast. And there's 3 more questions on recursion. Let's try to get to at least 1 more. So let's see. Let's move on to, let's try to do factorial. Let's see what that one's about. Okay, so factorial is forking, and let's see what we can do. Oh no, there you go. Okay, so write a recursive function that takes in a positive whole number and returns the factorial of that number. For reference, the factorial of a number is each positive whole number up to and including that number multiplied together. So in the case of 3, it would be 3 times 2, which is 6 times 1. In the case of 5, it's 5 times 4, which is 20, times 3, which is 60, times 2, which is 120. Go ahead. Oh, am I not sharing my screen?
Yeah, you're not.
Oh, I apologize. Okay, awesome. Can everyone see my screen now?
Yes.
Okay, perfect. Yeah, so so in the case of 3, we get 3 times 2, which is 6, times 1, which is also 6. 5 times 4, that's 20. Times 3, that's 60. Times 2, that's 120. Times 1, 120. So how could we solve this recursively? So again, we could always check num, right?
Can we
If
solve it?
Go ahead, Seki.
If num equals 1, return 1.
Okay, so if num is equal to 1, then return, oh, hello. Return 1. Okay, what about our else statement? What do we return here?
I will return factorial num.
Okay, so we return num. Okay, times factorial
Factorial num minus 1.
num minus 1. Okay, so let's see what that does. Awesome. So that gets us true and true. So
Can you please print that? That's what it's doing.
you want me to explain it?
No, print what it's doing. Can we print it? Is it possible to print to see what it's doing?
Oh, print what it's doing. Okay, gotcha. So let's print num. So we see 3, right? And I guess there is no way to printing this. Yeah, I can't really print this per se. Or actually I can. Let's see. Okay, let's do it with the first one so it's a little bit more clear. Okay, so we see that print num times factorial num minus 1. So the first print statement we see is 2. Then we see 6. And then we see 2 again. That doesn't make any sense. I guess the printing with recursion looks a little weird. So I can't necessarily print what's going on, but what's happening is 3 comes through, num equal to 1 is false. So it moves on to the next one. Now it's doing it's multiplying num times 1 less, right? So this is in fact just saying 3 times 2 times 1. And in all honesty, we probably don't even need the times 1. So what could we change here? Right? Because 2 times 1, any number times 1 is always going to return itself. So in all reality, I only need to check up to 2. So what do I need to change here on line 8 and 9?
Not sure.
If
We
num
got
equals
nothing?
2,
One more time, Andrew?
if num equals 2,
Yeah, if it's 2, and what should I return?
1,
Okay. So if I return
2.
1, yeah, awesome. And now we get 2. All right. Okay. Let's move on to the next one. We moved through that one quickly. There's the Fibonacci sequence, and let's try Palindrome together, actually.
Sorry.
Mm-hmm.
I don't understand about the 2 part.
The 2?
Yeah, line 8 and 9.
Oh, so we could use 1, right? But when you're multiplying something times 1, it's just going to equal itself, right? For example, 19 times 1 is still 19. So there's no need for me to go in another level to check if it's 1. Instead, as long as it's 2, I just want to multiply times 2 because there's no need for me to multiply times 1. I'm still going to get the same value as if it were just 2. Does that make sense, Eki?
Yeah.
Okay. I think you said yes.
I did.
Oh, okay. Awesome. Yeah, I'm sorry. I think there's something wrong with my speaker and it's not catching too much of the audio correctly. All right. Let's do Python. Some palindrome in Python. Let's see it. And we should have enough time to get through this. So let's try to do it really quick. All right, so write a recursive function that takes in a string word and determines if that string is a palindrome. If it is a palindrome, return the Boolean true. If it is not a palindrome, return the Boolean false. For reference, a palindrome is a word that is spelled the same backwards and forwards. Okay. Awesome. So how could we check that?
We can use the same method we use with the reverse, then have them then check if they equal, if both equals.
Oh, okay. So let's see. You're saying if word index 0 is equal to word -1, then what is it that you want to return? You want to return palindrome again, right? But what is it that you want to do to the word?
We want to compare both, so
I want to slice it, right?
yeah.
Okay. And then I want 1 to -1. Okay, but I think this might be an elif statement, right? Because the first thing that I want to check is if the length of the word is 2, right?
Yep.
And then I could return true. And then what else? Just return false.
Why are we checking length of what equals 2?
Because I want to make sure I work all the way down to the last 2 pairs of letters, right? So for example, in the first iteration, I'll have R and R. And this will come back true, but I want to make sure that it keeps doing it, and it needs a stopping point. It needs to know when to stop, right? This is just telling it how long to continue checking this for. But this is telling it when to stop. So if len, and I actually want to make sure it's less than, or no, actually we want equal to. We'll see how this works. We want to make sure that it checks all of this, that it checks those 2 letters are the same. So in this example, it's going to get down all the way to, oh, this is going to fail, actually. Yep. This fails. Let's see. We still got 5 minutes. Let's try to figure it out. So this is returning false, and it's not working the way we want it to. So maybe there's a different approach to this, right? How else could I check this? Any ideas?
Wouldn't you want the length to be greater or equal to 2? Because as soon as it equals,
I think we want it to be less than or equal to 2. All right, it's still going to return false because it's trying to check this. Because our last letter is just going to be 1 single character of E. All right, so we could always make another if statement saying if len word is equal to 1. Then it could return true because it made it all the way there. And this one we could just leave it at equals 2. Oh, that actually still returned false. So I wonder why it's doing that now.
Why don't you just make it smaller or equal to 1.
Make it smaller or equal to 1. So let's check.
And take off line 9. 10.
You said take off line 10?
Yeah. And make line 8 smaller or equal to 1.
Line 8 smaller or equal to. Okay, so it looks like it's going one time and then just returning false. So it looks like the problem is actually right here.
Yep.
And I'm pretty sure it's because I put that. Do you guys see I had that colon?
Uh-huh.
So I was actually slicing my word. So now let's see. Okay, so now it's returning true. So let's see, it takes in race car, compares R against R, then it passes in ace ka, compares A against A, then it passes in C against C, E, C, and then it returns E, and because it made it all the way to where there's only one word or one letter, it returned true. Okay, so let's check conifier and see if that returns false the way we want it to. Okay, so conifier returns false because C and R are not the same. So I never went into our second iteration of recursion. Okay, so let's check for help. And let's run that one. So again, it returns help. It looks at help, sees that H and P are not the same, so it returns false. And just to clarify, I just want to make sure that's actually returning true. Okay, good. And then our last occasion where it says evil olive. Okay, so that returns true. So it goes through, checks for evil. It sees that E and E are the same, V and V are the same, I and I, L and L, and then we got a space and O, I believe. But then it just judges space. It just judges O, and because O is itself, it returns true. Awesome. Does anyone have any questions over how we solve this recursively?
The second if statement, line 10. Do we actually need that in there?
Yeah, we do. So for example, let's say we had race car. But race car was spelled this way. Now there's an even number of letters, right? And it still returns true because it hits this statement. It says if the length is 2 and word 0 and O again is equal to -1, then return true. And I think that's the reason why this one was passing when it was supposed to fail. Oh, yep, there you go. Bring back the colon to slice it. There you go. Okay. Easy peasy. Did that answer your question, Akeem, about the second if statement?
Yep.
And actually, there should be an elif.
That's actually my concern.
Yeah. Hey, I'm human too, okay?
I was wondering why we have it to if statement, and when you explain again, and still, no.
Okay. Awesome. All right, everyone. That concludes our lesson for today. Let me stop the recording.